Welcome to day one of building an operating system from scratch. This is a hobby project that I've just started. So I'm calling the operating system as Maya. This is again, I don't see any like trying to have anyone use it. It's just I'm trying to build mostly just for myself. Try to understand how to build an operating system and code that. As far as this YouTube series or this video, my hope is that I'll do commentary on things, give updates on how the hobby effort is going on, what are the challenges, what are the things that I'm learning, and mostly that, instead of this being a tutorial or something. It's mostly updates on what I'm doing. All right, so I bought a course from Udemy to actually build a multi-threaded kernel. So I've got this started. So the tools that I use is so I need QEMU, which is the emulator. I need NASM to compile assembly. So let's go. Let me show you a demo of the current OS, and then I'll probably talk through some details. Right. So what we have here is I've booted up a emulator on my machine, and what's happening is that we have basically implemented a simple bootloader. So it's booting from the hard disk, and it's basically printing the letter M. Let me get out of the. Let me release the mouse. That is Control Option G. Right. I have control over my mouse. So let me close this, and let's walk through what we have so far. Right. So here is our assembler, the assembly file. It's a very simple program. It's basically a small bootloader that we have written. So this org is basically where our bootloader, this code will be loaded into in RAM. That's the address 0x7c00. Bit 16 means it's a 16-bit code that we are writing here. And let's go through this. How do we print this letter M, right? So what we're doing is we are loading up the register. So in this case, we are loading the AH register with 0EH. H is basically hexadecimal. So how it works is that we ultimately call this interrupt. So the hardware provides a list of interrupts that we can call. And when we call, for example, this interrupt 0x10, it's going to look into certain register to do some operations. And that's what we are loading up here. We are loading AH, the register, with 0EH, which is basically, I think, to do with how to manage the screen or something, right? And the AL register here is nothing but the character, which is M, that we want to print. BX is nothing but, let me show you a screen at what BX register is. So this basically is a, it's going to set something around, where it needs to be printed and some foreground and background color of how it gets printed. That's what the BX register is. And what we're doing here is this times is basically kind of like padding the entire sector up to 510 bits from the start of this code with zeros, and the last 2 bits is basically 0xAA55. Now this bit is crucial. So one thing that you would always think about is like how does the BIOS know how to load the bootloader? A bootloader is a simple program that is responsible for loading your kernel, right? And the BIOS first needs to load the bootloader, and how that works is the BIOS kind of scans all of your storage disks, for example, pen drives or your hard disks, and as it goes through each of those drives, it's going to look for a drive which has the first sector. So the memory is kind of like 512 bytes of sectors, and it's going to look for the first sector, and it's going to look for the signature. Does the first sector of the hard drive is ending with AA55? And if that's the case, then it knows that, okay, that is the bootloader, and then it's just going to load that program into 0x7C0. 0. I'll just show you a picture of how that works. So basically, this is a RAM on our machine, and I think so. In that RAM, I think they load a bunch of interrupt vectors, BIOS data, and the bootloader is specially starting at 0x7C00. That's the reason why we have ORG 067C00. I think this will be more used. I think it'll be used when we do offsets and jumps and sort of stuff. So I think it's a standard that BIOS loads your bootloader in your RAM at that location. And in our assembly program that we're writing, we're just saying that, okay, that's where it's going to be loaded, so that in the future when we do some memory address calculations, it's going to be useful. All right, so basically you have a boot.asm file, and so in order to compile it into binary, I'm just using this command nasm -f. The format is binary. I'm taking boot.asm and outputting boot.bin. So I can do that, and that would create this boot.bin here. We could actually disassemble the binary and look into it. So I'm just going to do that. Just a minute. I think there is a typo here. And disassemble is the command. All right, so it disassembled it, and you would see that the last, we have 55AA towards the end, and the rest of it is just it's just 00s, right? Yeah. So basically, what we're looking here at is in, I believe, if I'm not wrong, in the RAM memory, right, or the file itself. It starts with the first 2 bytes are basically B40E. I think so. Basically, in the x86 architecture, B40E means this specific command, right? So this is what the assembler does. When you compile this to binary, it takes move AH0XE and then converts it into B40E. That's what is stored on our .bin file, right? And the rest everything here is zeros. And I think as we go down, 1FD, which is nothing but I think the 512 at that sector end, we are storing 55AA. I'm not sure why we have this 00 here. I don't know, but some of it here is storing more things. So it's I think it's got to do something with the x86 architecture or something. But yeah, it's critical to note that the way that BIOS recognizes where your bootloader is, or if a particular hard disk has a bootloader, it's going to look into the first sector, and which is a 512-bit memory, and it's going to see, does the last 2 bits have the signature, right? So let's just run this once again. Just going to do QMO system. So basically, we're saying we're passing to this emulator, we are passing a drive, and that file is basically boot.bin, and we are passing format is equal to raw. And there we have our, so the emulator was able to read our file that we sent, and it recognizes that, okay, that's a bootloader, and then it's booting from the hard disk, and we are printing M because we are calling the interrupt, the interrupt 0x10 that prints this M. That is all for today. I will again continue to post updates as I continue to build and improve this operating system.